So this is a short discussion on the chain rule. That's the material in section 3.7. And so there's it's actually kind of the rule itself. That's all the lecture is about this rule. And so we're going to learn how to take derivatives of composite functions. So like look at this one, a function right here. Um, y is equal to 3x minus 4, the whole thing cubed. Well, if you don't have the chain rule, you know, if we don't have what we're going to learn today, you can expand that. Okay, so that, you know, it's a cubic. It's not, doesn't take forever, but it's a little inconvenient. But let's say that was to the fifth or to the seventh or something like that. Okay, so the first thing we have to make sure we can recognize the composite function. So we're going to write that as a function f of g of x. That's really, you know, something we learned in algebra, kind of talked about at the beginning of the course. And so the outer function, so we're cubing something. And then so the f is the outer function, and then we're cubing something, and what we're cubing is 3x minus 4. Okay, so you can actually think of this as f of g of x. F of x is x cubed, and g of x is 3x minus 4. Um, Sometimes you see this written as f of u is equal u cubed, where u, in this case, u is equal to g of x. Okay, we're not going to prove it. The proof is really not a very easy proof. Um, and so there's lots of, I mean, it's in the textbook. Every calculus book has it. You can just go on Google and go look at a proof of the chain rule if you're really very interested in that. Okay, but here is the famous chain rule. Something you're going to use in this course and the next course. So since make sure you can use this, I know you can go online and type these functions in and it will give you the answer, right? But you know, it's not going to necessarily help you when you really need it in physics or in Calc 2 or even if you take Calc 3. Um, so um, um, that's one version of the rule. So the derivative of, so let's say we have this composite function, f of g of x. And take the derivative with respect to x, the change with respect to x. So it's f prime of g of x times g prime of x. And I'd say a lot of you are going to kind of use it in that form. It'll get fast enough that you can just do that. Or some of you, I think, have seen it before. Another way to write it is dy dx, and I have this in some of my solutions. Dy dx is equal to the derivative of y with respect to u times the derivative of u with respect to x. In some of my solutions, I really break it down into the steps here. Um, so um, so let's just look at this one function right here. Okay, so and there's a lot of examples in this document, so we're going to look at a couple of them. So example 5, and now what we have is this polynomial x squared plus 3x minus 4 raised to the 7th power. And so there's something called the binomial theorem, which gives us a formula for expanding that. We don't actually have to. If we actually did without the binomial, if we didn't know the binomial theorem, it would take a long time to. It could be painstaking to expand that. Even with the binomial theorem, it's easy to make little errors, especially if you're collecting like terms. Okay, but we're going to learn how to take this derivative um, using the chain rule. Okay, so the function is, so f of u is u to, the outer function is f of u equals u to the 7th, and the inner function u is x squared plus 3x minus 4. And so of course now, hopefully we're good enough at these derivative rules that the derivative of x squared plus 3x minus 4 is 2x plus 3. And then the derivative of the outer function, which is u to the 7th, is the derivative of f with respect to u is 7 u to the 6th. And of course, you can just, you just replace, and remember, u is equal to x squared plus 3x minus 4. So, you just write that in here. Oh, it's written right down there. So this is df du, which is my terrible printing on the screen. Okay. So, right, so that's df du. And so then we just multiply them together. dy dx is dy du times du dx. And so then it's 7u to the 6, which is 7u to the 6 is 7x squared plus 3x minus 4 to the 6 times 2x plus 3. It almost looks like a quotient dy du times du dx. They don't really cancel. The du's don't actually cancel, but it's intuitive though, right? dy du times du dx. You cancel the du's and you have dy over dx. Okay, so that's one way of doing it. You just Okay, you just make, you identify the, you identify it as a composite function, you identify the outer function, which is f, you identify the inner function, which is g, and we'll call that u. So then you take the derivative of y with respect to u times the derivative of u with respect to x, and then you just make all the substitutions. And let's see. And then yeah, so basically, you can actually instead of x, there's that power rule. Derivative of x to the n is n times x to the n minus one. Let's say we're taking the derivative of some function of u raised to the nth power. Yeah, so then it just turns out the derivative is n times u to the n minus one times du. Okay, so that's kind of what we just did, right? Right, we just, so in this case, we took u to the seventh, right? In which case u in this case is x squared plus 3x minus 4. So actually, I did a couple of problems. There's a lot of problems in here. I did a couple in from the homework. And so, but here, let's look at number 13 here. So here's another one without the chain rule. That'd be kind of a, well, let's see, that would be kind of a painful problem, right? It's a quotient. 5x minus 4 raised to the third power, and 4x plus 7 raised to the fifth power. Okay, but let's say, if we didn't have the chain rule, how would we take the derivative of that function? Because we know that the quotient rule, we have to take the derivative of the numerator and we have to take the derivative of the denominator. Well, how can we take the derivative of the numerator and the derivative of the denominator without expanding if we did, but without the chain rule? So that problem will take a very long time. And of course, it's easy to start making arithmetic errors when we're expanding something like 4x plus 7 raised to the fifth. Okay, but now let's use our new friend, the chain rule. Okay, so so remember the quotient rule, we have it right here. It's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, the whole quantity, that whole expression divided by the denominator squared. Okay, so what do we get here? So we're not going to do all this u substitution here. Okay, so the denominator is 4x plus 7 to the fifth, and the derivative of the numerator, so we drop the 3 down, it's 3 times 5x minus 4 squared, right? And the derivative of 5x minus 4 is just 5. And now minus the it's the numerator 5x minus 4 cubed, and they have to multiply by the derivative of the denominator. So what do we have in the denominator? 4x plus 7 raised to the fifth. So you drop down the 5 times 4x plus 7, and then subtract 1 from 5, you get to the fourth. And then you have to multiply by the derivative of the inside, which is 4. So there's two. So we use the chain rule to find the derivative of the numerator and the derivative of the denominator. And of course, then you divide the whole thing by 4x plus 7 raised to the fifth squared. Now, students, you do want to simplify this if possible. So the one thing, we would not leave the denominator as 4x plus 7 raised to the fifth, the whole thing squared, right? You want to use the law of the exponents right there. And also, and in this case, we can also just factor out, so you have a factor of 4x plus 7 to the fourth here, and 4x plus 7 to the fourth there. And you also, a factor of 5x minus 4 squared and 5x minus 4 squared. So you want to factor out like terms, and so simplify when possible. Yeah, so in this case, yeah, you can even cancel. Yeah, so in this case, when you factor out, you have 4x plus 7 raised to the fourth over 4x plus 7 to the 10th. Yeah, then you have to use the law of the exponents. 4 minus 10 is 6. So you lose that factor of 4x plus 7 to the fourth from the numerator. But that's just all algebra. So the one thing about calculus, there's a lot of algebra. And if we start making mistakes in our algebra, we get the problem wrong. So so let's just finish with this document. Then I'll just show you a couple other examples if you still want to listen. Okay, so let's say, okay, so finding the tangent line to a curve, in this case, it's the secant of 2x. Okay, so the inner function, so we know how to take the derivative of secant, but now it's secant of x. But what about secant of 2x? Okay, so the outer function is secant of it, like secant of u, and u is equal to, the inner function is u is equal to 2x. So g of x is f of x is secant of x, g of x is 2x. And we want to find the tangent line at pi equal to 4. So one thing is, what is the ordered pair? So the curve secant of 2x, when x is pi over 6, we have, so the function is going through the point pi over 6, secant of 2 pi over 3, and that just turns out to be pi over 6, and secant of pi over 3 is 2. Yeah, so yeah, right. So yeah, because yeah, it's 1 over cosine of pi over 3, which is 1 over 1/2, which is 2. Okay, and then so now we actually have to calculate the derivative at pi over 6, right? We need to find the slope or the derivative. So we know the ordered pair. We know the tangent line is going to go through pi over 6 comma 2. What is the slope of secant of 2x, or what's the derivative of secant of 2x when x is pi over 6? So once again, we use our new friend, the chain rule. And so, okay, so the derivative of secant of 2x, right? So we'll use the chain rule. So it's secant of 2x times tangent of 2x. And then we have to multiply it by the derivative of the inside, which is 2x. And the constant we typically multiply on the left. So so during your calculations, you put that times 2 on the right. The 2 should actually be the lead term. And so then now so we know the derivative of secant of 2x is 2 secant x, tangent 2x, plug in pi over 3 in there. So we get 2 times secant of pi over 3, and then times tangent of pi over 3. And it turns out that's 4 square root of 3. So that's the derivative. This is the slope, 4 square root of 3. So yeah, so the tangent line, the equation of the tangent line is y minus 2 and equal to the slope 4 square root of 3 times x minus pi over 6. So yeah, so the rise is y minus 2, the slope is 4 square root of 3, and the run is x minus pi over 6. So now, students, is a special surprise. Yeah, it's my big surprise. Okay, so problems, yeah, some problems from the homework. Okay, so basically, so I'm just going to do is a couple more of these problems. This game, first one, I think I will use that u substitution here. So square root of 10 plus tangent squared of x. So that's a pretty wild function. Like just a few weeks ago, like the day one of derivatives. Let's say you had to do that from the definition of the derivative. Doesn't look like a lot of fun. I'm not sure I could do it. Okay, so anyway, find the derivative. First, let's find the derivative of tangent squared x, which itself, we're going to need the chain rule, right? Because it's u squared. It's a composite function. So let f of x equals tangent squared x. Let u equal tangent of x. Du dx is secant squared x. F of u is u squared, and df du is 2u, right? I'm right here. Df du, right? So f of x is tangent squared x, u is tangent x, du dx is secant squared x. F of u is u squared. The derivative of f with respect to u is 2u, or let's just go back to x, it's 2 tangent x. So the derivative of tangent squared x is df du times du dx. And we just multiply that. We multiply, so it's 2 tangent x times secant squared x. Okay, and students, some of it you could probably just, you're going to maybe feel comfortable enough with this, the chain rule, that you could just go, drop the 2 down, 2 times tangent x times the derivative of tangent, which is secant squared. Okay, now let's find the derivative of the square root of 10 plus tangent squared. So the inside function is 10 plus tangent squared, and the outside function is square root of u du dx. Now we just computed that. That's why we did all that work. The derivative of the constant 10 is 0. The derivative of tangent squared x is 2 tangent x secant squared x. And now we're going to take the derivative of y with respect to u, and it just turns out so that that's u to the 1/2. So it's 1/2, and we subtract 1 from the exponent. So it's 1/2 times u to the negative 1/2, or 1/2 times 1 over the square root of u. And this replaces u with a 1 plus tangent squared x. So dy dx is dy du, which is 1/2 times 1 over the square root of 1 plus tangent squared x times du dx. So it turns out the derivative is 1/2 over 1 over one time, let me start again. dy dx is dy du times du dx is 1/2, 1 over the square root of 1 plus tangent squared x times 2 tangent x secant squared x. And students, simplify. So we don't want to keep those 1/2 times 2 because that makes us look like we don't know what we're doing. So and then oh, if I was in a classroom now, I'd say, hey, does anyone have any questions? And I meant, maybe someone would ask a question, or maybe not. Okay. So I was going to say maybe most people would be looking at their cell phone, but I guess. Okay, so let's just look at this one here. Okay, so let's see here. Okay, okay here. So let's calculate the derivative of this following function. Okay, so once again, now students, you actually don't need, this is one where, I mean, theoretically, you could expand 9x plus 4 cubed. You could write it as 125x cubed over 9x plus 4 quantity cubed and expand 9x plus 4 cubed. Again, I think that's a lot of work. But plus, the whole goal here is to use the chain rule. So I'm just doing it this kind of faster way. So let's just drop down, right? We're just going to drop down the 3 and we write 5. I'm going to do my best here. 5x over 9x plus 4. That's terrible. Yes, we drop the 3 down. So we drop the 3 down, and it's 3 times 5x plus 5x over 9x plus 4, and then we subtract 1 from the exponent, so we get 2. But now we have to take the derivative of 5x over 9x plus 4. So now we have to use the quotient rule. So the quotient rule is the derivative, it's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. So that's the 9x plus 4 times 5 minus 5x times 9 all over the denominator squared, which is 9x plus 4 squared. Now, students, this is correct. It's like this part where I'm just circled, that is correct, but it's really not a very good answer. I mean, if you left that in a math, you're taking a test and you hand it into your teacher, your math teacher, they're probably not going to be happy because why? Because we haven't simplified. So let's simplify when we can. And so one thing we know is, well, let's use the law of the exponents. So 5x squared is 25x squared. And the denominator, well, I kind of jumped ahead here. The denominator is 9x plus 4 squared. And so we have these two terms, 5x over 9x plus 4 quantity squared. Well, the denominator is 9x plus 4 squared here. And then we have another 9x plus 4 squared here. So altogether, we add the exponents. So the denominator of the final answer is 9x plus 4 squared. Now, this problem was set up really in a very nice way so that a lot of terms drop out. So if you actually simplify this, it turns out what you just get is 20. So we get 3 times 25x squared over 9x plus 4 raised to the 4th times 20. And we multiply all the constants together, 3 times 25 times 20. And it turns out we get 1500 x squared over the quantity 9x plus 4 to the 4th. So that's a good answer, right? So we simplify, we multiply all the constants together. We just don't kind of leave it, just all this kind of stuff, these loose ends. So another version is, we can just recognize we're cubing something. So if you want to use the U substitution, if that makes it easier for you, then I really encourage you to do that. So we realize that we're cubing something. So we write y of u is u cubed. In this case, u is the inner function is 5x over 9x plus 4. So dy du is 3, right? 3, we drop the exponent down, 3u squared. And let's just substitute, let's put let's go back to x. So it's 5x over 9x plus 4 quantity squared. And then we have to du dx. And again, we kind of did that calculation already. And it turns out it's 20 over 9x plus 4 squared. And so now you just multiply them together. dy dx is dy du times du dx. And now what do we get here? We get 3 times, here's the du dx. This is the du dx. That's dy du, right? That's dy du. So it's 3 times 5x over 9x plus 4 to the squared. And then this is du dx, 20 over 9x plus 4 squared. And then you just simplify, and I skipped a bunch of steps. You get 1500 x squared over 9x plus 4 to the fourth. Okay, so that's actually, so all these problems with the chain rule are kind of like this. You identify the inner function, you identify the outer function, and then you just multiply, derivative of g with respect to y times the derivative of, I'm sorry, the derivative of f with respect to g times the derivative of g with respect to x. And the other thing, students, I'll just say, is that there is a lot of algebra in calculus. So it's a lot of, for some of us, that tends to be the sticking point, or it can be a huge sticking point. So if you make any algebras along the way, just make sure you understand them so you don't repeat them. So